Dear students, in the class we are going to discuss about the partial differential equation and introduction. This is the definition for partial differential equation. A partial differential equation that is simply we can write that PDE is one which involves partial derivatives. That is, we can put on the full screen. That means a partial differential equation is one which involves partial derivatives. That means it contains one or more partial derivatives. Is it not? Otherwise, in other words, we can write the definition like that. The equation which contains one or more partial derivatives. So we can ask the question now, what is meant by that partial derivatives? What is meant by partial derivatives? Let f of x comma y is equal to z, where z is the dependent variable x and y are the independent variable. That means z is dependent on the two variables x and y. Then we can write the first order partial derivatives. What are the first order partial derivatives? That means already z equal to f of x comma y is given. You have to differentiate z with respect to x and with respect to y. You will get that dou z by dou x. Similarly, you have to differentiate z with respect to y also. So here we can write that notation p and q respectively, small p, small q. So small p equal to dou z by dou x, small q equal to dou z by dou y. This is the first order partial derivatives. So we can write that the equation, first order partial differential equation. How can we write that first order partial differential equation? That means the equation which contains that only the first order partial derivatives. So simply we can write that, for example, 2p plus 3q equal to z. See here, it contains only the first order partial derivatives p and q. So this is the very simple example for the first order partial derivative. In the first order partial derivative, there are two types of the equations are there. One is linear first order partial derivative, partial differential equation. Non-linear first order partial differential equation. See, for example, linear first order partial differential equation means, very simple example, p plus qx equal to some x plus y. If you are writing like that, so here p and q power is 1, q and p power is 1 here, p power is 1 and q power is 1 here. So therefore this is the order 1 and degree also. Order is 1, degree also 1. But if you are writing that non-linear, what is meant by non-linear? Non-linear means, in case the order is not 1 of the first order, for example, case if you are writing that p square plus q square equal to z square is there. See here, p and q are the first order partial derivatives, but that the power is 2. In other words, in case if it is multiple of p and q also, this is the first one example. Second example, we can write that in case pq equal to z, then this is also the non-linear first order PDE. In case if it is that dependent variable is multiple with that the derivatives, that is also the non-linear partial differential equation. Then what is the second order partial derivatives? Second order partial derivatives is that the given function is that equal to f of x comma y. If you are differentiate z with respect to x or y twice, so that is known as the second order partial derivatives. So if you are differentiate 2 times z with respect to x, we will get that dou square z by dou x square. Generally it is denoted by small r. Differentiate z with respect to x, then with respect to y, we will get that dou square z by dou x dou y. It is denoted by small s. And then in case if you are differentiate z with respect to y 2 times, you will get that dou square z by dou y square equal to, that is denoted by t. Example for that second order partial differential equation is simple example. In case we can write that r plus t equal to 2s. That means dou square z by dou x square plus dou square z by dou y square equal to 2 into dou square z by dou x dou y. This is one of the example for the second order partial differential equation. Then what is the application of this second order partial differential equation? Generally in most of the mechanical department or electrical department, even computer science department, finance department, many of them are using this partial differential equation concept. Wherever that the rate of change of phenomena is there, and then if it is in the one direction, two-dimensional motion, then we have to go for the partial differential equation. So that PDE is connected with that various physical and geometrical problems. So wherever two or more independent variable involved in the problem, wherever the two or more independent variable involved in the problem, then we can choose that partial differential equation. Generally, sometimes the heat transfer problem is there. Heat transfer. Heat transfer is that it is denoted by U. Then U is x comma t. It is depend upon the two variable x and t. So usually on time t, and we can take some other space variables. Most of the problems in fluid dynamics, PDE applications. What are the specific some topics for the fluid? A PDE application is fluid mechanics. In the fluid mechanics, you can see that the heat transfer problem, momentum transfer, and then mass transfer problem. All this type of problems based on the partial differential equation, and then elasticity. For example, simple harmonic motion, electromagnetic theory, and quantum mechanics. So these are the few fields involved that partial differential equations. Mainly, what is the difference between that ordinary differential equation and partial differential equation is any physical problem in one-dimensional motion for example, a car is moving on the road or any particle moving in only one direction, then we can use that ordinary differential equation concept for that modeling that the real-time applications. Whereas in case two-dimensional motion problem, for example, in case any particle is moving, in case we are taking one space, in the space any particle is moving here, for example, in case if it is one ant is there, that ant is moving in that surface, that is either maybe move in the x direction or y direction, so that path of the ant is like that. So it is a two-dimensional motion. Even the three-dimensional motion, that is in space, any aircraft or motion of a rocket or launching a rocket, is like that three-dimensional motion. So at the time we have to use that the partial differential equation. But compared with that physical motion, partial differential equation is somewhat difficult compared with that one ordinary differential equation, and then it is somewhat easy, but it is somewhat difficult to solve. Even also model that problem is also somewhat difficult, but it is in the real-time applications that most of the time we have to form the partial differential equation. The third one, the function should be the function of one variable. That means it should be only one independent variable, only one dependent variable for this. But whereas for the partial differential equation, it should contain it's the first point, it's the second point, and then it's the third point. It should contain that two or more variables. That is, it may be that z equal to f of x comma y. In general, we can write that z equal to maybe that x1, x2, xn. N number of variables also we can do that for the partial differential equation. So these are the few points we want to discuss for the introduction of the partial differential equation. In the next class, we will see that how to form the partial differential equation from the given problem. There are two types of the problems are there. In the upcoming class, we will see that the formation of partial differential equation by eliminating that arbitrary constant or eliminating the arbitrary forces. Thank you for watching the class. See you.